All right, let's talk about, well, first of all, is everybody okay? Yes. Does everybody finally have power and internet back? Yes. Well, usually with power, there's the internet. It's usually not like no internet.
I don't get my internet until Sunday.
Ooh, why is that?
Xfinity sucks.
I don't have a problem with them.
Really?
Yeah.
Maybe just in my area, but I don't know.
You're in the States?
No, Naples Park.
Are they still building houses?
Yeah, but mostly just rental, seasonal rentals.
Because usually, like the places that they're building houses, when they dig, they'll like cut the line, and then they gotta come back and go, okay, crap, we gotta rerun the line again, and that's what usually happens. So to a lot of different places. All right, so this is what I'm gonna do. So we're gonna stay the course, meaning exam 3 is exactly when it's gonna be. Exam 4 stays. Everything stays exactly as is, right? Because there's so much material that it's almost impossible to not stay the course. Now, for you guys, one of the things that I did the Monday, because on Monday we were told that we had class. It was remote, so you guys didn't have class. One of the things I said to them was, hey, right now we still have power. We still have Wi-Fi. Nothing's happening yet. Storm's not here yet. So the closing and the remote is an anticipation of it coming. So one of the things I said to them on Monday was, hey, really like buckle down and get as much stuff as you guys can get done on Monday so that whatever's due by the end of the week, get it done. This way, on Tuesday, you guys can be present with your family, and whatever needs to be prepared can be prepared, and go from there, right? This way you don't have to worry about, oh my goodness, what am I going to do about the due date, this, due date, that. Now, some of you guys are still very young in terms of you're just out of high school or you're still in high school for some of you guys. The one thing I'm going to say to you is that you're in college now, okay? No matter if you're a high school student or not, you're in college. So as a college student, it's like the intermediate phase of, or the interim phase of going into adulthood, right? And one of the things is that there's going to be moments and times where you're going to have to take care of business, meaning you're going to have to learn some of the material on your own. Luckily for you, at least for this course, you at least have videos to back it up, okay? Where we still need to stay the course. So sometimes people will tell you that being an adult sucks. It's because of those things. You have to take responsibility. You have to meet the deadlines no matter what, and you got to do those things, okay? Even if you want to be your own boss, same thing happens. You're still going to have to take responsibility for things. You still got to get things done. You're going to have to still ignore those other things. Where in high school, a lot of times what happens is that you guys get to go, hey, we got a day off from school. That means I can sleep in late. I can stay up late and stuff like that. As an adult, you can't. You still got to get stuff done. Right? There was plenty of people that were still at work on Tuesday. Plenty of people that were still at work on Wednesday. Still plenty of people at work on Thursday. Right? And that was pretty much through the storm. Heck, I live in Ave Maria. Arthrex is right next door. There are cars there working. Right? So no matter if Arthrex in Naples closes, Arthrex in Ave still is working. We're in different zones. I didn't know what zone I was in until someone asked me, so I had to look it up. I'm in zone F. Zone F. I told my boss that I don't make enough money to know what storm surge means. So some of you guys are very lucky. to actually know what storm surge means. Homie here does not have the right to even know what storm surge means. It's like when you buy a house in like zone A and zone B, you're like, hey, here's a book. This is what storm surge means, right? And I figured that if zone F ever has a mandatory evacuation, that means we're all effed. I think that's why we're called zone F. If zone F gets called, we're all effed, right? That means Naples is definitely going to be underwater, for sure, like North Carolina was, right? So we're going to stay the course. I'm going to treat lab work 8 as an optional lab work, so the people who got to hand it in early and on time, I'm just going to give 100%, and I'm going to ask Canvas to drop another lab work so that we can stay the course. This week, we got 6.6, 11.2, 11.3, 11.4. The reason why 6.8 and 6.9 I'm going to say on your own is because that is literally steps to do exponential regression and logarithmic regression. I will kind of fly through it a little bit just so you guys know, but there is a video on that, so you guys are welcome to do that. Now, I did already revamp their Canvas homepage. So if you guys look at Canvas, you will see that this is already revamped, right? You see that week 9, all the videos are there. Week 10, still the exam 3. Week 8 says Milton. If you guys have already clicked on it, it will give you a little giggle. If you guys haven't clicked on it, feel free to do that and have a little giggle. It's just fart noises for a minute long. Okay? Different types of fart noises. Some juicy, some not so juicy. Because that's what we think of Milton now. Right? Now that's passed. All right? But again, that's all revamped. So this is what we're going to do. Week 9, that's what we're going to do. And then week 10 is going to be exam 3. Now, 11.2, 11.3, 11.4 is something that you might have to revisit the video because that is some rough stuff. So one of the things is that going from intermediate to college algebra wasn't bad because there was a lot of review stuff in there. It was until we got to exponential functions and logarithmic functions is when it was like brand new stuff. You're like freaked out. And then it was like, oh, it's not that bad. And even going from college algebra to here, there's been a lot of review stuff, right? So in college algebra, there was one exam that was brand new stuff. Here in pre-calc, you're going to have 2 exams down on brand new stuff. Chapter 11, 12. Chapter 11 is going to be exam 3, brand new stuff. And then chapter 12 and 13 are going to be brand new stuff as well for exam 4. So exam 3, a little bit of brand new stuff. Chapter 6 is really not brand new stuff. It's supposed to be review, but we'll go over that. And then chapter 11 is all brand new. So I'm more concerned about that than chapter 6 because I want you guys to really get to know it. Okay? So let's get into 6.6. Any questions for me at this point in time? In terms of, now, did everybody that got the email about turning on notifications in Canvas, did you guys turn on your notifications? Yes? What happened yesterday when you turn on the notifications? I changed all the due dates for the MLM. So you should have got like 20 notifications, 20 plus, because every single assignment from first day of school till now is all due this coming Saturday for MLM. So if you didn't get those notifications, that means you didn't adjust your notification for due dates. Okay? So make sure that you do that. Any questions on any of the other chapter 6 part stuff? Do we have a question about lab work 8 at all that was an issue? that you had a question about before we get into this? I should probably bring it up if that's the case, right? Yes?
For question two, I couldn't figure out where the 7 came from in the final answer. I kept like reworking the problem in a bunch of different ways, and I could never get a 7 as a denominator.
Ooh, and is an equation, so it's something that we're actually doing today. Why is that in lab work 8? Oh, because we were supposed to get that done, weren't we? So that's why you guys needed to go through 6.6. Let's do that one. All right. So number 2 said 2 plus log base 3 of 2x plus 5 minus log base 3 of x is equal to 4. Okay. So what do we do first? Okay. So I got to subtract that 2 over to the other side. So I got that. Awesome. So we got the so-called quotient rule. I see what you're saying now. I had to write this down and go, oh yeah, that's what he was trying to say. Right? That's what you're trying to say. So since we don't know how to figure this out or solve for this, we convert it to an exponent form. Right? So the base goes over to the other side, log goes away. We're good with that part. No problem. Awesome. You see it now? Now, before I box this answer, I always need to make sure that I can use this in here. Meaning, if I was to put 5/7 in that parentheses, or I shouldn't even use that one, I should use it up here, right? Will it force me to take the log of a negative number? Because remember, the domain of log is 0 to infinity with not including 0, right? Because we can't take the log of 0. Because there's a vertical asymptote at x equals 0, right? So I got to make sure that that solution plugged in here won't give me a negative number, or plugged in here won't give me a negative number to take the log of. As long as if I'm forced to take a negative, then I have to reject it. If it is positive, then I'm good. Does that make sense? Okay? Cool. Any other questions on lab work 8? So I really don't have to go through 6.6 then, you're saying? No. Okay. Thank you for voicing that, for sure.
I did take the notes from the video, but still gaps.
No problem. No problem. Was there anything else in lab work 8 that was like, man, I really need some help on it? Was that the only one?
There was more, but I didn't write them down.
Okay. Do you want? If I put it up there, would it help? You see it?
Yeah.
Okay. Let's do that. No. Why would I mind for? Not at all. Was there anything there? That's 5 and 6. So that should cover 6, 6. I mean 6, 8, 6, 9. Okay. And then this is 7, 8. Same thing, right? Well, 7 a little bit different, but 8 is the same thing.
I did have a lot of trouble with 7 because I just didn't know what to do.
Okay.
I went to like the MLM and started working through those problems, and it made a little more sense to me. But it still doesn't make a lot of sense.
Okay. So essentially, with number 7, the way I would do it is that I would plot the given equation. After I plot that, I would pick out some points there. And then did the exponential regression, just like this is giving me points, right? So I would take those points given by this, right? And do you guys know how to do that on Desmos? I'm not sure how to do it on TI, but on Desmos, if I was to, oh, there it is. So that right there is the equation. And if you hit, here, let me do it this way. It'll be easier. Oh. So here, if I hit the gear, right? See on that equation, I have 3 things there. If I hit the Excel, what looks like an Excel table, if I hit that table, it will show me those points. So essentially, I created a table of some of those points, right? So I was like -2, -1, 0, 1, 2, and then over here I put down 46.815018, 83.79, 8883, 150, 268.5, 480.615. And then in this equation, since that is a 2 now, so I make sure the log mode is on. This is x2, y2, so y2 is approximately that. And it will give me my A and my K.
I just, to find K, I found it easier to just take the natural log.
Okay.
And then K stays.
Gotcha. Wait a minute. You took the natural log of E.
No, B.
Oh, of B.
From the original.
You took natural log of both sides.
The natural log was 1.79, and that equals e to the power of.
My lab says B equals E to the power of K, and I'm going to change that. It worked with our questions and the questions in my lab.
But question is, why does it work? Why does it work? That's where my mind goes. Why does it work? Does that make sense? Because in order to take the natural log of 1.79,
I think it's because b to the power of e and e to the power of kt, they equal each other. Because they're both being multiplied by like the initial amount of b.
let me think here.
They just cancel out the initial amount.
So essentially, they're just saying that e to the k has to equal to 1.79. Now you can take the ln. Because that's ln is the opposite operation of e. So that's what we're saying. Makes sense. That's why I was asking why. That was the biggest question. So in the lab work, as long as you can show this, that would make sense, right? So that's what has to be shown in order to go, okay, got it, right? Even the B wouldn't really work either. Because you say e to the k is equal to b. Oh, but you said the b was equal to 1.979. Because again, I want to make sure that we don't remember more to do the same amount. Does that make sense? I want to remember one thing to do multiple things, right? So if I can just make the connection rather than saying b is equal to, you know, a naught equals a naught times b raised to the kt. Instead of remembering that just to do the same amount, I'd rather make the connection of what we already know. If that makes sense. Okay. All right. Any other questions? Was there anything else from 1 through 4? Nada? Okay. Okay. All right. Then let's run through here. So again, for this first example, because it's in log form and there's no other logs, right? I can't condense, I can't expand. So from there, the key point with this one is going to be to convert. And I can box this answer because 2 doesn't force me to take the log of a negative number. Agreed? There's actually two ways of doing this. There's actually two ways of doing this. I know the obvious way that you guys can see. Do you know what the other way is? So I'm going to guess that you're thinking, just like the way I just did number 2, right? You would just do the quotient rule, right? Convert it to exponent form and go that route. That's one way, right? So I always told my college algebra students, here's where questions, how does your mind work? Ready for the other way? Here we go. Did you know that I can convert this 4 into log base 4? I can rewrite this. Here, let me do that. Change it to blue. This would be log base 4 of 4 raised to the 4th. Because, what does that equal to? What's log base 4 of 4? It's 1. I guess I could do it this way too. Actually, I'd erase that. As long as the two bases are the same, they're opposite operations of each other. Just like taking the square and the square root. Okay? That's the reason why I had to raise it to the 4th, because the power rule will bring this to the front. Log base 4 of 4 is 1, so 4 times 1 would be 4. Okay? Now from here, yes, I still got to do the division rule, or the quotient rule here. But since they're both logs, that means those are equal to each other. Any questions on that? Does that make sense? Okay. So I can take any regular number and convert it to that log base. So I could have done it up here as well. So this would have been log base 3 of 3 raised to the 4th. Right? So I could have done it that way. This one here has a product rule. Since they're both LNs on both sides, I can just say that the inside does it make sense I reject the -2? Yes? Because if I put -2 back in, it forces me to take the ln of a negative number, which is a no-no. 1 is fine. Also on the lab work, you have one that the bases weren't the same, right? If the bases aren't the same, and I can't get the bases to be the same, then I can use either common log or natural log. Okay? So this is where I can use common log okay? I like using natural log only because it's 1 level rather than 3 levels. Okay? It makes my fraction look neater. So essentially what I'm going to do is I'm going to take the natural log of both sides. I got the power rule. So what am I solving for here? When I'm solving for things, what am I usually solving for? You're solving for x, right? So I got to solve for x. Now, ln of 5, what is that? I can plug that in the calculator, right? Same thing with ln of 3. Those two are just numbers. Just like if this was a 5 and this was a 3, right? Just a number, right? So whenever I'm trying to solve for x and they're on both sides, my goal is to get all the x's on one side, all the numbers on the other, and divide off what's attached to the x, right? So I would do exactly the same thing. So here I'm going to have x ln of 5 minus 2 ln of 5 is equal to 3x ln of 3 plus 2 ln of 3. I want to get all the x's on one side. and numbers on the other. What do I have on the left side? So that would be considered your exact answer. So if they're asking for exact answer, that's what you have to put in. If they're asking for approximate, then type that in your calculator and whatever it gives you, it gives you. So there's the same idea here. First, I want to isolate the 3 to the x. So I'm going to divide the 8 off. And then I would take the ln of both sides. Because I can't get the base to be the same. So one of the things I do love or want you guys to do, or would love for you guys to do, is that when you guys are looking at these problems and you see me solving these, I want you guys to think of, is there a different way of doing it? Right? Just like you guys were saying about that other problem. Love it. Right? I want you guys to think about, without the help of MLM, of course, right? Something that you would think of to do it differently. Just like I was showing you that problem compared to the problem that was asked, right? 2 different ways of doing it, but getting to the same answer, right? So that is something that I would love for you guys to do. Power rule. Oh, sorry. Let me do this. Questions? We're okay? No questions. None whatsoever. Are we sure? Here we go. Woo! Parabola that you've never seen before. We're going to be talking about parabola, ellipse, and hyperbola. You're going to have these looks that you've never seen before, okay? So with a parabola, you got a couple of things. We've always known about the axis of symmetry the axis of symmetry is divided into the center of it, which goes through the vertex. You guys heard of vertex before. Here's the vertex. All right. However, this is also done with a directrix. Okay? Is it always done with a directrix? Why is a directrix important? The directrix is always the same distance as the vertex to the focus as it is from the vertex to the directrix. And not just that. Not just that. Every time you draw a perpendicular line from the directrix to any point on the parabola, this distance right here, it's equidistant to from that point to the focus. And that is what this thing is saying. This is the distance from the focus to the point is the same distance as a point to the directrix. So that's what it's saying. So every time you draw a perpendicular line from the directrix to the point, from that point to the focus, it's always the same distance. So if I was to draw this distance right here, perpendicular to the directrix, and I know that these two distances are the same, let's call them A. So that means this would be 2A. So therefore, from that point to the focus, also will be 2A. And I'm pretty sure there's some things in that, in the lower notes is wrong about the 2A. So, but there it is. Okay. So, some new words for you guys is directrix. Focus. So those are going to be two of the key new words for you guys in the parabola. The directrix is only going to be in a parabola. The focus is going to be in all three sections. There's going to be a focus in the parabola. There's going to be foci in the ellipse, meaning two. More than one is foci, plural for focus. And in the hyperbola, there will also be foci, two focuses, two foci. Okay? So those are some new words for you guys. So, you guys are looking at this table going, what the? All this table is saying is this, okay? With a parabola, we already know we can have smiley face parabola. We can have a frowny face parabola. We can have a sideways parabola or the other side parabola. Russ? Does that make sense? Okay? So that's why on the directrix, I couldn't say it's going to be a y equals, because if it's a sideways parabola, it'd be a x equals. Make sense? Okay? So the nice part is that most of the parabola that you guys are searching for isn't going to be sideways, angled like that. It's not going to be diagonal like that. Okay? However, if they present to you a problem that's diagonal like that, just straighten it out. Make sense? Just straighten it out, because then you're going to find everything else that you need, right? So, all these equations are saying is this. If you look on the left side, you see y squared and x squared. If it's an upward-facing parabola or a downward-facing parabola, is that x squared or a y squared? is an x squared. If it's facing up, we know that A is positive, smiley face. If A is negative, frowny face. But I know it's going to be x squared because most of them are going to cross the x-axis twice. So when you guys see x squared for AY, opens up. X squared, negative at 4a, face down. If it's sideways parabola, chances are it's going to cross the y-axis twice, no matter which way I go. Make sense? Question is, which one is positive, which one is negative? But think about this, though. If I had this right here, crosses the x twice, but notice where it's pointing, towards the positive infinity, versus this is pointing to negative infinity. Hence, the A is negative. So therefore, if this is the case, then I should be pointed towards positive infinity. Opens to the right. So for your frame, it would look like this, right? Isn't that positive infinity for you guys? Negative 4a opens to the left. Isn't that pointing to negative infinity? Okay? So it's things to think about there, right? And this is assuming that the vertex is at 0, 0. Right? So these are the easy problems. So the question is, what would it be if it wasn't, if the vertex wasn't at 0, 0? But anyways, before we get there, let's show this right here. Right? Still the same thing. The only difference is that they're just showing the vertex is at 0, 0. That's all they're showing. Okay? So if it's at 0, 0, this is 0, comma A. This is, right? This is going to be at negative A, because if this is A away would be negative A. That's all it's showing. Okay? So no big deal there. So if the vertex is not at 0, 0, it's at some kind of HK, which you guys heard of, yes? Right? We talk about HK with the center of the circle. We talk about HK with even the vertex form with a parabola, right? Same exact idea. The x is squared, the y is squared. The A is positive, the A is negative. A is positive, A is negative. Still opening the same exact way. So x is squared, A is positive. X is squared, A is negative. X is squared, A is positive. Y squared, I'm sorry, yeah, y squared, A is positive. Y squared, A is negative. Still the same. Okay? It's just the vertex has moved. So that's all this is showing here as well. Now, so here's where your issue comes into play. Good news is this. Good news is this. Exam 3 and exam 4, you guys will have a cheat sheet given by me to you as a present during your exam. Okay? It will look like these blue tables. So you understand the blue table, great. But I don't think you need the blue table. I think you just need the essential of the equation. That's all. Okay? So that's the reason why I tell you guys, think about x squared. What does it look like? Y squared. What does that look like? Oh, that's the other thing that you guys are going to have to know too. Oh, I will put it in brown. The other word that you need to know is this. The latus rectum. That's why I put in brown. I don't know why they call it latus rectum, but that's what the name is called. So I figured brown would be the right color. Latus rectum. I'll explain what the latus rectum is soon enough. Okay. So let's look at an example. And just so you guys know, all of these notes has a blank version of it. So you guys are welcome to just print those out as well. okay? And rewrite those. Oh, look at you, making it look nice. Except that's like 3 pages before. You can just go on Canvas and just download it, and then just throw it right into Notes, and you'll have it.
Yeah, I mean, I do the notes before I come to class.
All right, so find the equation of the parabola described. Find the 2 points that define the latus rectum and graph the equation. The vertex is at 0, 0. Axis of symmetry is y-axis containing the point 5, 3. There's that word latus rectum. All right, so the red highlight is the vertex. I plotted it already. It's at 0, 0. 5, 3 is in blue. Plotted in blue. The axis of symmetry is in purple, so I plotted the purple as the axis of symmetry. So as we know, there is a symmetry to this, right? So because we know that this is here, and this is 1, 2, 3, 4, 5 spaces away from the axis of symmetry, I know that 1, 2, 3, 4, 5 must be the other point. That means my parabola oh boy, that's not going to let me do that. Let me try to do the best I can here. E C 6 8 9 E C 6 8 9 Hey. Close. So one of the things is that just because it gave me these points, I cannot assume that the focus is through those 2 points. So how the heck am I going to find this? So since it's going through, well, number one, I know it has to face up, yes? I know the vertex is at 0, 0. So if it faces up and it's 0, 0, that means x has to be squared. Since it faces up, my a has to be positive. Do we agree with that? Can I find a with this equation? Yes. Right? Do I agree with that? Because I have a point. I have this equation. I can find my a. So you might be asking, why are we finding a? Let's make sure that we agree that a is equal to 25 over 12. Yes? Which is what, 2 and 1/12? Right? Just a little bit over 2? Okay. Because what I know, and the reason why I wanted this A, is because what I know is that the focus distance from the focus to the vertex has to be A. Are we okay there? Yes? Okay? So, again, the distance from the focus to the vertex has to be A. The distance from the vertex to the directrix also has to be A. This is the reason why I don't mind questions at all, okay, for that exact reason. So, with that being said, that means the directrix has to be also A, so it's going to be right here. So this is my directrix. So what is the equation of this directrix? Has to be y equals what? Here, I'll help you. Negative. Does that make sense? Because what I know is that this distance here has to be A, and this distance here also has to be A. So since that A distance is negative 25 over 12, right? So far, so good? And don't forget that the distance from the vertex to the directrix is also equal to A. So now the question becomes, what the heck is a latus rectum? A latus rectum is a line that goes through the focus from one side of the parabola to the other side of the parabola. This right here, ladies and gentlemen, forms the latus rectum. Go ahead. Ask your question. He can't get past rectum. Trust me, I don't get past rectum either. So many things to say. Any questions on that so far? We're okay? Go ahead. Side of the parabola. Yep. And it's going to be perpendicular to the axis of symmetry. How far do you think that distance is? The lattice rectum. Ooh, close. 4a. Because was that in fraction form? 3. So, but it doesn't want the distance though. It wants the points. So it wants this point and this point. So remember, if I was to draw a perpendicular line from here to here, right? This distance here, as you guys can see, is 2a. So from here to the focus must also be 2a. So this distance here is 2a. And this distance here is 2a. So again, let me write that. So this distance here is 2a. This distance here is 2a. So the lattice rectum is actually a sum of 4a. However, it doesn't want the distance of that. However, the distance helps us find this point and this point. Question is, what is that point? I know what the y value is. Because I know what the focus is, right? If I know what the focus is, I know what that y value is. But the question is, what's the x value? Well, if the a is 25/12, what would 2a be? Which is? Agreed? So maybe a good advice to have is this. Once we find A, we should also find what 2A is equal to. So let me bring this down. Maybe a good advice is saying, what is 2A equal to? Just so that we have it. Oh, mistake, 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 mistake. There we go, fixed. Make sense? That has to be negative, right? You're like, wow, that was a lot of work for a parabola. Any questions here? Yes, so the lattice rectum is a line that is perpendicular to axis of symmetry or parallel to the directrix that goes through the focus, heading from parabola to parabola. Yes? Yep. The focus is the distance of A from the vertex, so that's how we found the focus. We had to find the focus in order for us to find the directrix. And from here, we can actually find the point of the focus right now too, right? Because that's 0, 25/12. That's how we found the directrix, which is y is equal to negative 25/12. But again, this is assuming that the vertex is at 0, 0, right? Which that's what was given in the problem. All right. Let's try a problem where it's not at 0, 0. Find the equation of the parabola described below. Find the 2 points and define the lattice rectum and graph the equation. Okay, so the vertex is negative 1, 5. The focus is 1, negative 6. Does this open up or open down? Vertex is here, focus is here. Does it open up or open down? Has to open down. Has to open down. Where's my directrix? Directrix. Right, it's going to be an equation of a line, right? Huh? Almost. Oops. Okay. What's A equal to? 1. Because what's A equal to? A is equal to, from the focus to the vertex is A, right? Which is 1. That's why we knew about the directrix. We know that this has to open downward, so let's do the best guess here. Okay, that's a straight line. That's nothing. This is literally just a sketch. I have no idea if this is the right drawing or not. Okay? I won't know until I get everything else done. Actually, you know what? Let's just not put it in there. Because I can actually, let's just leave it. Let's just leave it aside for now. I know it's going to be open down. Okay. Based on this, what else can I find? Awesome. I can find the lattice rectum. Since this is A, I know that 2A would equal to 2. So that means from here to here, oops, sorry, not that one, here. This would be my lattice rectum. Now I can actually do this, right? Wow, my drawing was way off. Say low. Say low. Oh man, is it that? Close enough. Okay, can I write this equation of this line? Because what is squared? Is x squared or y squared? X is squared, so I know this is going to be x minus h squared is equal to, is just 4ay? Or is it going to be negative 4ay? Negative 4ay. Do we know where all those numbers came from? Not too bad? Please don't look like you're going to barf. All right. Let's see here. Focus is at -3, -1. I got the directrix at x equals 5. Okay. What should I look for? Oh, sorry. What should I look for? Great. Where's my vertex located? Right here? Agreed? Okay. So what did that just give me? We can find our last rectum, but what do we need to know first? We need to know A. What's A? So 2A would equal to 8. That's my latus rectum. Oh, you're right. So you're saying this opens to the left? Yeah? Wow, that's going to be a weird graph, huh? Oh boy, I don't even know how far I went there. Of course. Okay. So how do I find this equation again? What squared? X squared or y squared? Is that my equation? Are we okay? Yeah? Are we sure? So with a parabola, it's pretty easy to remember, right? X is squared, or x squared a is positive, x squared a is negative, x squared a is negative, x squared a is positive, right? We know we know that. We know the questions to ask ourselves to know which direction those go. So on Thursday, when we talk about the ellipse and the hyperbola, okay, there's going to be, so over here, we really only needed to know one distance of A, right? Because the last rectum was 2A, and 2A makes 4A. So we know that. So the problem with the ellipse and the hyperbola is that you're going to need to remember 3 different distances: an A, a B, and a C. And the relationship of the A and the B and the C is different for the ellipse versus the hyperbola. Okay? So that's what we're going to be talking about on Thursday. The A, the B, the C. And then that's what it's going to create those shapes. Okay? So these are brand new to you guys. So again, it's something that you guys are going to have to kind of get into. And obviously when you guys do the review, the cheat sheet will be there, so you know exactly what's going to be given to you. But understand that this, so you guys know, chances are I'm going to give you the whole cheat sheet, the one for exam 3 and the one for exam 4. Exam 3 is only on one side, exam 4 is on the other side. So on the final exam, that's the 2 cheat sheets you're going to get. Okay. So please do understand that. All right. If there's no other questions, ladies and gentlemen, please have a wonderful, blessed day. Please be safe. Love you guys. See you guys on Thursday. Later.